To answer this question, we need to understand how exponents work on the number line. If you're a number to the right of 1 and you start multiplying yourself times yourself, well, then you keep getting bigger and bigger and you go farther and farther away from 0. But if you're a number between 0 and 1 and you keep multiplying yourself times yourself, then you're just multiplying a fraction times a fraction times a fraction, and every time we multiply by a fraction, we go closer to 0. So a number between 0 and 1 would actually get closer and closer to 0. It would get smaller as you raise it to greater and greater powers. What about negative numbers? Well, that's a bit more complicated because if the exponent is even, you'd get flipped over to the other side of 0 and turn into positive. But if the exponent is odd, you'd stay on the negative side of 0. So all of a sudden the divisibility of the exponent matters. If it's a multiple of 2, then you'd turn positive, and if it's an odd number, you'd stay negative. But other than that, it's the same concept, right? If we're to the left of -1 and we multiply ourselves times ourselves, we go farther and farther away from 0 because we're multiplying by numbers that are greater than 1 in absolute value. And if we're a fraction between 0 and -1 and we are raised to a power, we get closer and closer to 0 again because we're multiplying by fractions. So with that said, under what circumstances would x cubed be smaller than x squared? Let's figure that out right after the intro. So based on everything we discussed so far, x cubed would be smaller than x squared in one of two scenarios. It would happen if x is a positive fraction between 0 and 1, because when you multiply itself times itself 3 times, that would bring it closer to 0 than if you only multiply it times itself twice. The other scenario this would happen is if x is negative, because with a negative base, an odd exponent would keep it negative and an even exponent would make it positive. So for any negative value of x cubed would be smaller than x squared, just because of the fact that x cubed would be negative and x squared would be positive. So that's what we know from the free info. Right? We know that x is either a positive fraction or it's negative. They're asking us for the value of x, and I have to say, so far there's an infinite number of possibilities. So let's look at the statements. Statement 1 still has an infinite number of possibilities because there's an infinite number of numbers or fractions between -2 and +1, and any of those could be the value of x. So let's eliminate the answer choices that claim that statement 1 is sufficient on its own. A and D are gone, we're down to B, C, E. Now statement 2 tells us two things. It says that x is an integer, and it also tells us that x is greater than -2. So what are some integers that are greater than -2? It could be -1, it could be 0, it could be 1, it could be 2, it could be 3, etc. But remember, we know from the free info that x is either a positive fraction or a negative number. So if we know that x is an integer, that excludes all the fractions, and we know it's greater than -2, and we know from the free info it does have to be negative, how many negative integers are there to the right of -2? Just one. So we can now infer that the value of x is exactly -1. That's the only possibility given statement 2. And therefore the correct answer is B. If you found this video useful, go to quantreasoning.com for a lot more where that came from. You should also click that like button and let me know in the comments below what you'd like me to make future videos about. And of course, if you haven't yet subscribed, go ahead and do that and click that bell below so you get notified about future videos. See you next time.